This lesson focuses on a number of different machine components, and it's divided into different columns. I want you to look at this page as that being the half. So this section continues on this side, right? So what I'm going to do is, not to confuse you, and to make it a slightly bigger, I'm going to divide this page perfectly into half there and fold it and only focus on this part here and then go to this part once I've completed this part over here. Okay, let's do that. So there are 1, 2, 3, 4 columns. This column gives you the name of the component, which is very important, and I'm only going to focus on the main name of the component. This gives you an idea of what it looks like in reality. This is the view that you will see in 2D, but this is very important, the convention. You need to know this for your analytical question, the convention, and you need to know the name. So I'm going to highlight those two specifically. This is just to give you an idea of what it's like. This they will ask you in the exam or test, and this is what you need to produce or present. So the first thing that we're going to be looking at is a compression spring. And I'm highlighting the word compression spring. You know what the spring looks like. There they give you a view of it. This is how you draw the convention. Center line here, center line there, center line there. It starts with a straight line and it ends with a straight line, and you just do it in that angle format till there. Right? Center line, center line, center line. Straight line at the bottom, straight line at the top, finishing it off, and your in-betweeners are slanted lines. Let's go to the knurling. The knurling with the silent K is this component here. It's a wheel or a handle that has almost like grip sections on the outside, and the grip sections could be either in a diamond format like it is there, or it can be just in a line format. That is to allow that there's grip and that it doesn't slip when turning or closing grip components or handles. Right? That is what the knurling convention looks like. Straight lines, or it has a diamond shape as you have it there. Alright, that is basically what a knurling is. Then we go to the bearings. So these are bearings. You will find that the bearing has an inside casing and an outside casing, and there are balls separating the inside and outside casing. So you can actually keep the inside stationed so that it doesn't move, and the outside will actually move as fast as you can turn it. Right? It's normally in skateboards where you have this inside the wheel of a skateboard, and the axle is attached to the inside part of your bearing. There you can see there's the axle, and the bearing fits perfectly on the axle, and there are the balls that go and separate the outside from the inside part there. This is how you draw the convention. You have the shaft, you have a square block on top and a square block at the bottom, and it is indicated with 2 crosses for the bearing that we have. Alright, let's look at basically an S-brake, what we call an interrupted view. So this view shows you the actual shaft. Sometimes shafts are very long. You won't be able to fit it on a page, but you are allowed to draw the front and maybe the back part of the shaft or a certain component, or the middle part, and you have an S-brake like that there, which is slightly hatched at the top or at the bottom. But what it means is that this shaft is actually longer than this drawing here, that it continues. This actually continues longer than the actual drawing. That's basically what it means. Then everybody knows what a spur gear is. That is a normal gear, which is a wheel basically with teeth on the side or on the circumference, and it allows for mechanical advantage. We don't normally draw the teeth as it is in the pictorial view, so we draw it as a double line like that there, and you can see it's a double line. The one line is in fact a chain line, and the outside line basically refers to the outside part of the teeth, and that chain line, the inside part of the teeth, right? And the shaft obviously go through there. The shaft goes through there, and you have a keyway there that locks the shaft to the gear, the spur gear. And there it has been cut, the full section, which we spoke about now. There's hatching, cross hatching, and there, because there's contact with the metal. Here's the in between the teeth, it's not cut, in between the teeth, not cut, and the shaft opening basically doesn't allow for hatching there as well. Then we move to the S-brake again, just to show you a different way, or on a different shaft. There it is, the shaft, different shafts, and there's S-brakes again. And there they show you how to draw an S-brake. It means that it continues, it's longer than the actual size on the page. Then we have the basic treatment of symmetry, or when things are symmetrical. So symmetrical means that this one side here, this half here is exactly like that half there, or this bottom is exactly like that top there. When components are symmetrical, we don't normally draw everything, but you are allowed to draw one side, like there the draftsman only drew one side, and that was the half line there. This would have been a mirror image here, but he didn't draw it, not to waste time, but he included that double line here, like that, or it can be horizontal like that. There's only a quarter, because it also shows that it is symmetrical all around. Here the whole component, there only half with the double lines here, which shows symmetry. Okay? And that component can be horizontal or vertical as it is there. We go to the opposite side of the page, where we have holes on a linear pitch. So that's holes in a single line. Linear means a straight line. So that basically tells us that we want to drill holes all around this linear line, horizontal and vertical. When you draw the convention, and I want to highlight the convention, you don't draw all the circles where you want to drill the holes, but you only indicate the centers of those circles, and just one hole there. The same for holes on a circular pitch. There are a number of holes on a circular pitch, like it is there, and to be able to identify where you're going to drill that in the convention symbol, you only need to mark the center points of the circle or the holes which you are going to draw, and you don't need to actually indicate them all. That saves a lot of time. We look at a dowel. The dowel, boys and girls, is basically a cylindrical metal, or it can be wooden, but in this case being mechanical, you will have a rod which is referred to as a dowel. It goes into holes to secure certain things. Right, there is a dowel from the front side, this is from the side. Then a square on a shaft. A shaft is normally a round component. There is a round component, and then there's a square section, and then there's a round. But when you look at it like this, you won't be able to say what it is. So normally it's indicated with a cross like that. Now we know. Here we won't know, but there we know. That cylindrical shape, that is a cylindrical shape, but this part here is a square hole through it. That is a square on a shaft. That crossing, that diagonal, so cross actually tells us, as well as that cross there, that that's a square, that's a square. This is a cylinder, that's a square hole inside, and that's a cylindrical shape. We have an external screw thread, which means on the outside, there is your bolt, and the thread on the bolt is on the outside, so it's external, and you will find that in the convention, it will be on the outside. We don't normally draw thread like that in mechanical drawings, but we draw it as a double line. You can see here as a double line, one faint line on the inside and a solid line on the outside. Right. Let's look at the internal thread. Sorry, the internal thread is there. So we will find that when a bolt goes into a piece of metal, the thread on the bolt will be on the outside, which is external, but the hole where the bolt is going to go into will have internal thread like it is there. So that previous bolt will go in here. That is internal thread, indicated with a double line as I explained in the previous component. Alright, and then we have screw threads, basically, which we just spoke about now, how to draw it. It's double lines. We're not going to draw it like that. Then a spline basically would be teeth around square teeth around a wheel. Similarly, like the holes, you are not going to create all the teeth in the convention, but you only need to do the middle one and one on both sides of the center, and that would suffice. Then you continue with the double lines, which is the outside part of the teeth and the inside crest part there. Similarly, like the serrated shaft, where it is pointy teeth with points on the outside, you are going to draw maybe just one or two, one center one and one on both sides, and then you continue with the external line and the internal line, which is the crest of the teeth here, to be able to show that on the pulley or wheel or gear, to put it that way. And that is basically what it looks like in reality. I hope you enjoyed this video, and it makes a lot of sense that what we have discussed, you will apply all this information in your analytical and in your mechanical assembly drawings.